Hello guys, I hope you're all fine. Today we are here to discuss about two area control. If you observe here, this is control area 1, this is control area 2, this is the tie line. If losses on the tie line are neglected, then the power exported by area 1 is P tie comma 1 equals to modulus of V1 V2 by X12 into sin delta 1 naught minus delta 2 naught MW. Then it will become like this. If the incremental tie line power for area 1 is delta P tie comma 1 equals to T12 dot into delta 1 minus delta 2 into pu mw, let it be equation 1, whereas here the t12 naught is modulus of v1 into modulus of v2 by pr1 into x12 cos delta 1 naught minus delta 2 naught. Here the incremental frequency is delta f, which is equals to 1 by 2f into d by dt of delta. Here it will become like this delta, and also here if you observe here, this delta is 2 pi into integral delta f into dt, let it be equation 2. Here from these two equations, from equation 1 and 2, we can write like delta p tie comma 1 equals to t1 2 naught into this, like let it be equation 3. Similarly, incremental tie line area power exported for area 2 is delta p tie 2 equals to this one, let it be equation 4, whereas t21 is here, if you observe here, this t21 is this one, modulus of p1 into modulus of v2 by pr2 into x12 into cos delta 2 naught minus delta 1 naught. Here it will become like p max comma 21 by pr2 into pr1 by pr1 into cos delta 1 naught minus delta 2 naught. Here cos of minus theta equals to cos theta, so we can write like this. So it will become like this, t21 equals to, if you observe here, t21 and also t12, if you observe these two equations, t21 and t12, here these two, t21 and t12, then we can say like t12 equals to pr1 by pr2 into t12 naught, which is equals to a12 into t12 naught, let it be equals to 5. Here the power balance equation for two area system, when the power is transferred from area 1 is delta pg1 minus delta pd1 equals to 2h1 by f0 into d by dt of delta f1 plus b1 delta f plus delta p tie comma 1. Here if you apply Laplace transform, then we will get this equation, let it be equation 6. And by taking the Laplace transform for equation 3, which means if you observe here, yeah, this is the equation 3. If you apply Laplace transform from this one, then we will get like this, let it be equation 7. If you apply Laplace transform for equation 4, which means this one for equation 4, if you apply Laplace transform for this one, then you will get this whole equation, let it be equation 8, let it be equation 7, and let it be equation 8, let it be equation 7, and let it be equation 8. Then here for equation 7, if you observe here, for equation 7, this is the block, whereas for equation 8, this is the block, we can draw like this. Whereas here area control error, ACE1 equals to delta p tie 1 plus b1 delta f1. If you apply Laplace transform, then we will get like this. Here whereas for area 2, ACE2 equals to delta p tie comma 2 plus b2 into delta f2. Let it be, if you apply Laplace transform, then it will become like this. If you observe this block diagram, this is two area load frequency control. Here we will add two basic blocks, two area controls. Whereas from figure C, from this figure, from the above figure, from figure C, we can say that change in line power plus b1x change in frequency, which is equals to 0, which means delta p tie comma 1 plus b1 into delta f1 equals to 0, let it be equals to 1, whereas delta p tie 2 plus b2 into delta f2 equals to 0, let it be equals to 3, whereas delta f1 minus delta f2 equals to 0, let it be equals to 3. Whereas here we know that delta p tie comma 1 equals to 2 pi t12 into integral delta f1 into dt minus delta f2 dt, integral delta f2 dt, whereas delta p tie 2 equals to 2 pi t2 into integral delta f2 dt minus integral delta f1 into dt. If we do like delta p tie 1 by delta p tie comma 2, then we will get like this, which is constant, let it be equation 4. Here equation 1 and 2, which means these two equations are satisfied only when delta p tie comma 1 equals to delta p tie comma 2 equals to 0, whereas delta f1 equals to delta f2 equals 0. Under steady state condition, change in line power and frequency in each area is 0. Whereas if you observe here, this is the dynamic response, this curve represents change in tie line power due to step change in area 1, whereas this waveform represents change in frequency of area 1. This is all about the two-area load frequency control. I hope you understand, guys. This is all about the two-area load frequency control. Thank you, guys.